Identify the center and radius of the sphere x plus 1 quantity squared plus y squared plus z minus 4 quantity squared equals 144. And then after that, we will determine if this equation here is that of a sphere, and if it is, find the center and radius. Okay, so in both of these problems, it's going to be key for us to know the equation of a sphere. So a sphere in R3, here's a sphere. It's got a center point, which we'll say has coordinates h, k, l. And then the definition of a sphere is all points in R3 that are equidistant to the center, and that distance is called the radius. So a point x, y, z is on the sphere if and only if the distance between x, y, z and the center HKL is equal to this radius. So the distance between these 2 points, x, y, z and HKL, is given by the formula x minus h quantity squared, y minus k quantity squared, z minus l quantity squared. Add those together, take the square root, and you have the distance formula in 3 dimensions. Notice that if you were just to ignore this part, this is the distance formula in 2 dimensions. So this is supposed to equal the radius of the sphere, and then squaring both sides gives us the equation of a sphere. X minus h squared plus y minus k squared plus z minus l squared is equal to r squared. And again, if we were just to ignore this third term, then x minus h squared plus y minus k squared equals r squared is the equation of a circle with center hk and radius r in the xy plane. So by adding the third component here, we are getting the equation of a sphere in three-dimensional space. So this equation that we're given here, put it in this form, x plus 1 quantity squared is the same as x minus negative 1 squared, and y squared is the same as y minus 0 squared, and then z minus 4 squared we can leave alone, and 144 is 12 squared. So we're just matching that equation up with the general equation for the sphere will tell us that the center is at HKL. H is negative 1, K is 0, L is 4, and the radius is r squared, 12 squared, radius is 12. So this is a sphere with center negative 1, 0, 4, and radius 12. Okay, now we would like to take, here's a second degree equation in the variables x, y, and z, and we would like to show that this is the equation of a sphere and determine its center and radius. So we want to put this equation in this format. So we'd like to see perfect squares here. So we will complete the square. So recall that if we have a polynomial of degree 2 of the form x squared plus ax, and if we add to that a over 2 squared, then this is a perfect square. It is x plus a over 2 quantity squared. This is called completing the square. So we have here the x terms, x squared minus 8x. That has this form. And then we have y squared plus 12y. That also has the same form, but with a variable y instead of x. And we have plus z squared plus 2z. Same form again. And we'll put the minus 20 over to the other side. So for each of these second degree polynomials in the variables x, y, and z, we will add an appropriate constant, and we'll put that constant on both sides of the equation. So the first one's going to become, take half of this number, negative 4, square it, 16, and add it on. And that means on the other side of the equation, we're also going to have to add 16 at the end. And here, y squared plus 12y, we take half of the coefficient of y, which is 6, square it, 36, and add it on. And then z squared plus 2z, take half of the coefficient of z, which is 1, square it, still 1, and add it on. So on the right side we get minus 20, negative 20 is what we had, add 16, add 36, add 1. So plus 16, plus 36, plus 1. So now this is a perfect square. It's x minus 4 quantity squared. This is a perfect square. It is y plus 6 quantity squared. This is a perfect square. It is z plus 1 quantity squared. And this should be some positive number. So this is 53 here. Minus 20 is 33. And so that's a positive number. Radius will be the square root of that number. So sometimes we see a nice number here that is a perfect square, like 144, which was 12 squared. 33, the best we could do is say it's the square root of 33 squared. So our radius is going to be the square root of 33, and the center is at HKL, where we have to add minus signs in here. So y plus 6 is the same as y minus negative 6. So the y coordinate of the center is going to be negative 6, because we have to have y minus the coordinate. So a plus here has to get converted into a double negative. So the center is at 4, negative 6, negative 1. And the radius, as mentioned, is the square root of 33. Square root of this number. So we did have a sphere, found the center, and found the radius by completing the square.